The Phoenix mission was very exciting. During the landing of Phoenix, the topsoil was removed, splashed around the spacecraft. So the blobs that we saw in the strut of the Phoenix lander was probably a mixture of salt and melted ice. And during a few hours per day, each day, it would liquefy. Perhaps there is some bacterial life that could survive and even replicate in those water. The controversy is because this was completely unexpected. We went out to look for ice and to look for evidence of liquid water in the distant past. And right there, we were seeing evidence for liquid water. That became less controversial when Phoenix discovered a salt there, perchlorate, that could produce liquid at the conditions that we were observing there. What I proposed was to simulate the conditions at the Phoenix landing site and to study the formation of those blobs in the lab. You really need to do a simulation that can convince, yourself and the whole scientific community that something is possible. So most of the last few years, we spent developing the chamber, the only one we believe that we can simulate the conditions at the Mars polar region, controlling the water vapor pressure down to the very small amounts that we have in the polar region. What we found out is if we have just the south absorbing water from the air, in a few hours we don't see the formation of liquid. If we have ice and then the south on top of the ice, in a few tens of minutes liquid water form. Our measurements clearly indicate that. And it's really a proof that the liquid water form at the conditions of the Phoenix landing site when the south is in contact with the ice. Based on the results of our lab experiment, we expect the soft ice that can liquefy perhaps a few days per year, perhaps a few hours per day, almost anywhere on Mars. So going from mid-latitudes all the way to the polar region. This is a small amount of liquid water, but for a bacteria, that will be a big swimming pool. A little droplet of water is a huge amount of water for a bacteria, right? So small amount of water is enough for you to create conditions necessary for Mars to be habitable today. And we believe that this is possible in the shallow subsurface and even the surface of Mars polar region for a few hours per day during the spring.
Mars is a very dry and cold place today, and it may have supported a lot of water in the past. The question is, where did the water go? The idea for the project started about 28 years ago.